Okay, cool. So I'll go ahead and get started. Hi, my name's Tanvi Gehani, pronounced she, her, hers, and I'm a third year biomedical engineering major. And I am going to be the project lead for a new project this year for a portable gluten sensor. And this is something that I'm very excited to be leading because this sensor targets people with celiac disease, which I have myself. And so this is a topic I'm very passionate about. So we'll get started. So I'll start by talking about what is gluten exactly. So gluten is essentially a protein, a large family of proteins that's found mainly in grains such as wheat, barley, and rye. And it's essentially what helps foods maintain their shape, like breads, for example. It's what makes them chewy. It's what makes cakes dense. And it's commonly found in pastries, crackers, pastas, all those types of things. But it's also found in a lot of foods that we may not typically expect, like spices, specific sauces, and things like that. So now to talk a little bit about celiac disease. Celiac disease is a genetic autoimmune disease. Approximately 1 in 133 Americans have the disease, and it's essentially when consuming tiny traces of gluten will trigger an immune response that will attack your lower intestine. And this is problematic because your lower intestine is lined with these little projections called villi, and those villi help your body absorb all the vitamins and minerals that you eat and distribute them in your bloodstream. And your body needs vitamins and minerals for every single system pathway that you have in your body, from neurological functions to skin, digestive, heart function, everything. So when your lower intestine's damaged and your body's able to receive those nutrients, you're at risk for malnourishment. And if this goes untreated, it can lead to long-term issues, including cancer, osteoporosis, infertility, nervous system disorders, birth defects, and a whole bunch of others, since, like I said, you need vitamins and minerals for every single pathway in your body. There's currently no cure to celiac disease. Research on celiac disease is relatively new, so there's still a lot of research going on. So there's no cure right now except adhering to an extremely strict gluten-free diet. So the problem at hand is there are current devices on the market that are able to test small food samples to see if they contain gluten in them. But currently, there's no, these devices lack reliability in specifically detecting gluten in fermented hydrolyzed foods. And like I mentioned before, in celiac disease, even small traces of gluten can trigger an immune response. So it's really important that these devices are reliable. That way, the consumer, whoever is consuming their food, doesn't get those traces of gluten in them. That can, because even small amounts can cause intestinal damage. So combating this issue will reduce the likelihood of individuals consuming any traces of gluten unknowingly. So some examples of fermented hydrolyzed foods include beers, soy sauces, different types of vinegars, yogurt, pickles, types of cheese, and many others. Basically, any type of food that's fermented. It's these devices that are currently on the market are unable to, and FDA regulations to deem something gluten-free, it has to have less than 20 parts per million per sample in order to be safe to consume. So our goals for this project, like I said, this is a new project, is to essentially discover a method that will accurately detect hydrolyzed gluten in your food sample. And then once we're able to do that, essentially translate that protocol into a user-friendly portable device that's reliable and accessible to those who need it. So this is a tentative timeline. Like I said, this is a new project, and with COVID going on, a lot of things are subjective to change. But phase consists of extensive research. I'll go into each phase more in depth in coming slides. Phase 2 will be formulating our own testing approaches. Phase 3 will be executing those approaches that we come up with. Phase 4 will be designing a prototype and an approach to implement our method. And phase 5 will be to actually build that prototype. So more in depth about what each of those entails. So phase 1, like I said, will be extensive research. And this is something that can be completed virtually given our environment. And the kind of questions we'd be looking into would be basically the mechanisms of current products on the market. There's currently a product called the NEMA sensor that's able to detect gluten in pea-sized food samples, as well as also peanuts for those with peanut allergies. So basically understanding how does that system work? What does it do? And then another thing we'd be looking into is identifying different detection methods that are currently out there, whether it's antibody-based chemistry or ELISA or mass spectrometry or different types of chromatography. What are the different ways that we can identify gluten molecules in substances from a laboratory perspective? Then another thing we'd be looking into are what are the properties of gluten, and more particularly, what are the properties of hydrolyzed gluten? And why are the current mechanisms ineffective in being able to detect hydrolyzed gluten? What barrier needs to be broken? Kind of filling in those gaps. So that would be phase one, which would be a lot of literature review. Phase two would be formulating our own testing approach. Like, how would we go about testing? This is also something that could be completed virtually. It will involve a lot of collaborative discussion, and it'll basically involve filling in those gaps from phase one, connecting the properties of hydrolyzed gluten to current testing methods currently out there. How can we change current protocols out there to be able to accommodate for the gaps that are missing in hydrolyzed gluten? So we'll basically be doing a lot of comparing and contrasting of different methods, writing out our own protocol based off of previous protocols found in literature, compiling a list of materials and equipment that we would need. And yes, this is something that would be completed virtually, but during this phase, this is something we could look into is, for testing, are there any ways that any of these tests can be done virtually? And if so, like, what would those requirements be? What safety protocols and what costs would be involved with doing so? And that's something that could be looked into during this phase. Phase three would be to execute testing. Once we've narrowed down kind of our approach, say, for example, we want to go on an antibody route, antibody-based chemistry route, that we would take that approach and we would run our protocol. This is something that's anticipated to take place in person, but like I said, during phase two, if there are ways that this can be done virtually, again, depending on what the current COVID is like, those are all things that would be discussed during phase two. And more details for phase three would be discussed during phase two, but phase three is essentially implementing a protocol that we devise. Phase four would be designing a prototype, and this would come after we have successfully identified a method that detects hydrolyzed gluten and abides by FDA standards of 20 parts per million per sample. And so once we have done that, the next step would be to devise a way to incorporate that method into a device, going from translating science to engineering, essentially. And so this is where SolidWorks, AutoCAD would all come into play. We would assess appropriate materials and equipment, assess cost. And so that would be phase four. This is something that could also take place virtually given the appropriate software, given the softwares that we have access to. But hopefully things will go back to in-person soon and we'll be able to interact more in person doing all of this. And then phase five would essentially be building the prototype. Plans for this would be based off of what we come up with in phase four. And this is also something that's anticipated to take place in person. And hopefully by the time we get to this phase, we're able to do so. But like I said, all of these are very tentative plans. So how do you fit in? So essentially anyone's welcome to apply to be a part of the team, regardless of your experience. We're all learning. Like I said, this is a new project. Anyone interested in celiac disease, microbiome research, biochemical analysis, biomedical, medical, electrical engineering, all of that, anyone interested, highly encourage you to apply. We will be recruiting 2 to 3 committed individuals to be able to lead subgroups for specific research tasks, as well as when it comes to designing a prototype. And I'll be holding interviews for that next week. And so anyone interested in being like a subgroup head, if it's a plus if you have experience in SolidWorks, AutoCAD programming, because other members who may not be as experienced in those working in your group, it would be great to have a leader that would be able to help them gain more experience in that. And there'll be resources and tutorials provided as a way for you to gain more experience as needed. And phases 1 and 2, all that extensive literature review will allow everyone to kind of get on the same page as far as from a research perspective, and material perspective. Yeah, and so some of the team expectations, these are all very tentative. This is something that, like, when we form our final group, something I would want to talk out with you guys, get to know what works for you. So as what I have on here as of right now is meeting 1 to 2 times a week, an hour to 2 hours. Be enthusiastic and prepared. There'll be approximately 3 hours outside of meetings for independent research tasks, a little bit more for subgroup heads. And y'all will report to subgroup heads and myself as needed. And one thing I kind of want to emphasize is, like I mentioned, this is a new project, and celiac disease, like the research that's being done on celiac disease is relatively new. Anything being done on celiac disease is relatively new. So I think this gives new members an opportunity to be able to spearhead their own and initiate their own ideas and create your own legacy, and a way to kind of have your ideas be heard. There's no one way to do this, and I think that's kind of one of the good things about starting a new project. Anyone who has ideas, like, they will be heard, and we can make it happen. So yeah, and then these are some of my references, and if anyone has any questions, let me know. Definitely apply.